Hi, I'm Dan Klingman with the Lincoln Electric Welding School. Today we're going to go over some troubleshooting of GMAW welds. We have a SP140T wire feed welder. We're using 025 L56 MIG wire. And we have a 75 argon, 25 CO2 gas mixture. We're going to go over some of the common variables that are used for GMAW and what happens when those get out of range. The first one we're going to start with is going to be wire feed speed. Remember, as you increase your wire feed speed, the puddle gets hotter. You're going to increase the heat and amperage into your weld. So we're going to start and see what happens when you have too much wire feed speed. What you're going to notice is the wire is going to start to stub, and you're going to have to go back and adjust from there. So if we do realize we have too much wire, we can do one of two things. We can either take our voltage up or bring our wire feed speed down. So let's make a weld. So what you'll notice here is you could tell in the arc the wire was wanting to stub. We had too much wire for the amount of voltage that we had set. So again, to overcome that, we can either take our voltage up or bring our wire feed speed down. And for recommended settings, they will be found underneath the door of the machine. You can look up your material thickness, your wire type, and your gas type, and it's going to give you a starting point for that type of material. So that's the recommended place to get you in the ballpark before you start welding. The next weld we're going to make is we're going to have our wire feed speed too low. Now when we have our wire feed speed too low, you're going to start to see large droplets coming across the arc. So when we see that, we need to go back and make an adjustment and either turn our wire feed speed up or turn our voltage down. Now one thing you'll notice too is before I start to weld, I'm going to go ahead and trim the wire. Sometimes you'll get a little ball on the end of the wire, and trimming that off to a nice clean point is going to help your starts become a little bit smoother. So let's try too low a wire feed speed. So now if we look at the two welds we just made, the first one being too high a wire feed speed and the second one being too low of wire feed speed, we noticed on the second one that we made, we could see those droplets coming off there and they were very large. So we'd have to adjust for that. Again, we can either take our wire feed speed up or bring our voltage down to make up for that. And you'll notice that the crackling sound, we are using the short arc process for GMAW. So that sound that you hear is the wire shorting to the plate up to 200 times a second. So when you do get the right wire feed speed and voltage, you'll hear a real nice crisp crackle to the arc, and that's what we're going to be looking for here. Okay, the next variable we're going to look at for troubleshooting our GMAW welds is travel speed. I've got the machine setting used according to what settings on the door for the 10 gauge material. With that set, I'm just going to control my travel speed. I'm going to go too slow for this particular weld, and we're going to see what happens to the outcome of our weld. So if you notice by looking at the arc, we can see that the weld puddle is really piled up and our travel speed for this particular material was too slow. So next we're going to look at our travel speed doing too fast. We're too fast of a travel speed. Again, our machine settings have not changed. All we're going to do is go too fast for that particular wire feed speed and voltage. You'll notice we won't get the follow of the puddle like we're looking for. So now the last weld we made, was our travel speed was too fast. You can see how narrow our weld was, and if you notice the puddle, it was not keeping up with me. So this first one is too slow, and the second weld is too fast. Now we're going to look at the effects of our contact tip to work distance. With the short arc MIG process, you're looking for a fairly short contact tip to work distance. We've got it set here to about 3/8 of an inch. If you can maintain 3/8 of an inch, that's a good starting point for your MIG setup. So what I'm going to do is I'm going to actually go further out and make a long contact tip to work distance, and we're going to see what happens to our weld. So we just made our MIG weld with too long of a contact tip to work distance. First of all, what happens is as that contact tip to work distance gets longer, our current goes down. So you can see our weld is real convex and humped up in the middle, and it did not wet out very well. And what will happen with the GMAW process, if you get too far away, you'll eventually lose your shielding gas and you'll end up with porosity in the weld. So we want to maintain that approximately 3/8 of an inch for our contact tip to work distance. Now we're going to look at too short of a contact tip to work distance. We're going to go ahead and make a weld, and you're going to notice that I'm too close to the plate, and a couple things could happen. One is my nozzle could drag in the weld behind me. The other one is that my contact tip to work distance is so short that it'll actually burn back up into the tip. So let's make a weld and see what happens. So we just made a weld with a contact tip to work distance too short. And you can tell a couple different things. One is right here at the end, you can see where my nozzle actually drug on the top of the weld bead. The other thing is it's really hard to see the puddle and to follow the joint when you're welding on a joint. So make sure we try to maintain that roughly 3/8 of an inch stick out, and then we'll be able to make a lot better weld. Next, we're going to talk about the effects of our shielding gas. For the GMAW process, our gas mixture that we have here, our 75 argon, 25 CO2, is what's protecting that molten puddle from the atmosphere. So it's very important that we have the proper coverage for our weld. The one thing is we could have too low of a flow rate and we won't get adequate gas coverage. The other thing may be that we have contaminants on our base material and we'll start to get pinholes and porosity involved there. The other thing is we don't want to use too much gas. Too much is not better. What happens is as you turn the flow rate up too high, number one, you're wasting gas. Number two is you'll start to get a swirling effect, and that's actually going to bring in the air and also contaminate your weld. So use the recommended factory settings on your gas flow rate. For this particular setup with this small nozzle, 15 cubic feet an hour is typically fine. And we're going to go ahead and make a weld here. We're going to demonstrate the effects of either no shielding gas or too low of shielding gas or possibly even contaminants on the base metal. But one of the most important things in troubleshooting a weld for a GMAW process is if you're getting holes and things like that in your weld, go to your gas first. Check your plate, check your settings, and it'll typically be one of those. So let's see what happens. So we just finished our weld with not enough shielding gas. And as you can see, there was a lot of spatter and the weld was getting contaminated from the oxygen and nitrogen in the air attacking that molten puddle. So again, you can tell by the amount of spatter, and you also see the pinholes in the crater of the weld. And that's going to tell you to go back, check your gas shielding setup, make sure your connections are tight, and then you can make a good weld. We're now going to cover the polarity for GMAW or gas metal arc welding. Gas metal arc welding operates on DC electrode positive. And on this particular SP140T, if we open up the door, we can reference the correct polarity for the process that we're welding with. So if we look here, we've got our L56 MIG wire, our 7525 gas, and it's recommending DC positive. That means that our work cable is going to be hooked to the negative output stud here, and our lead from our wire feeder will be hooked to the positive terminal. So now we're going to demonstrate a GMAW weld on the wrong polarity. Remember, GMAW welding processes operate on DC electrode positive. We're now going to make a weld to show you for troubleshooting what it looks like at the arc when you try to run it on DC negative. This is a common mistake made, and now that you'll know what to look for, you can hopefully prevent it from happening. So let's make a weld. So as you'll see, we just made a weld on DC negative with GMAW's short arc. And you can see the large amounts of spatter in a very inconsistent arc. So remember, make sure before you make a weld, especially if you're going back and forth between flux cord self-shielded and gas metal arc short arc, make sure you check the polarity first. Flux cord self-shielded on DC negative, gas metal arc short arc process on DC positive. Now we're going to look at some different angles involved with GMAW welding. You often hear the terms work angle and travel angle. When we talk about work angle, it's our angle to the joint. So if we're welding this way, it's going to be typically for a T-joint or a lap joint, it's going to be roughly 45 degrees to the joint, okay? Now for something like this where we're just doing a bead on plate, we can actually be perpendicular to the plate. When we talk about travel angle, that's whether we're going to be dragging or pushing. Now, when we have the GMAW process, we can either drag or push. Just be aware of what the outcome of that weld will be. When we drag the weld, we're going to get more penetration because we're right on the leading edge of that puddle, but our weld is going to be a lot more convex or humped up in the middle. When we push it, we tend to get a little bit better shielding gas, but it also flattens our weld out, and we get less penetration because we're riding that puddle and not right down on the leading edge. So again, either one you can do whatever you feel more comfortable with. Just make sure you're aware of the outcome of the weld. The first one I'm going to make here is I'm going to make a weld with the drag technique. So we just made a weld using a drag technique with the GMAW short arc. And you'll notice there's very little to no spatter, so our machine settings are correct, our wire feed speed, our voltage, even our travel speed. It's just that when you drag it, you'll notice that the weld is a lot more convex or humped up in the middle. But again, you will typically get more penetration on that type of weld. The next weld we're going to make is we're going to use a push. Rather than a drag, we're going to push the gun from right to left. If you're right-handed, trim the wire, and now we're going to use the push. So we just finished making a weld with the pushing the gun, and you'll notice that it's actually a little bit wider and it flattened out the weld a little bit. So again, really no right or wrong, just be aware of what the circumstances are. You notice that I wasn't really putting any motion or movement into the gun. Some people like to do that. Otherwise, you can just do a steady motion down the plate, but it's up to you as you put in the different circles and things like that. Just make sure that you're not undercutting and you're filling in when you're doing that. Sometimes a rule of thumb is that the more movement can be more room for mistakes. So just make sure you're watching that puddle and you're filling everything in, and your results will be good. We covered wire feed speed. We covered our travel speed being too high or too slow. And we also covered the effects of our contact tip to work distance and all the effects of our angles, our work angle and our travel angle. So just again, read that puddle. That's going to tell you what you need to adjust. And if you need more information on welding, you can visit lincolnelectric.com.